Okay, so let's go ahead now. We're kind of armed with the change of base formula or whatever we need to solve quadratics or exponentials. So let's do that. Again, the rule, the idea, the game plan is very similar to the logarithmic one. What we want to do is take the exponential part and we want to isolate it. And then once we get there, we apply the logarithm. We either do a conversion or we apply any logarithm that we want, because as we saw with the change of base formula, we can basically do that. So looking at the first one, what I have, right, there's the exponential part, and it's being multiplied by 3. So the first thing we need to do is get rid of that 3, so I'll do that by dividing both sides by 3. So we get 4 to the x power equals 25, right? And now what you guys have are a couple of ways to do this. One is to do a straight out conversion. If I do that straight out conversion, this becomes x equals log base 4 of 25, right? And then you can use your change of base formula and go from there. Or you can apply any logarithm that you want. And since the ones that are on my calculator are log and natural log, I'll apply one of those. So let me go ahead and do the log. So if I apply the log to this, right, whatever we do to one side, I do to the other, so we get that. Right, and then using our logarithmic exponential rule, we bring the x out here. We get log base 4 and log of 25. And then divide both sides by log 4. And we now have a way to put that on my calculator, which was the same as our change of base formula. So either way, you're going to get here, right? Somehow, some way. You either could do a straight out conversion, realize, hey, that's a bad power, bad base, so I'll change it. All right, and come down to there, or you just apply a logarithm that you have and then just do the work. All right, and so in this case, doing the work here, we get, let me turn it on, we get the log of 25 divided by the log of 4, and our value is 2.3219-ish. All right, so in this case, x is 2.32192. Okay, yada, yada, yada. There's a whole bunch. All right, so that's the solution to that exponential equation. Same thing over here. Here's the exponential part, and there's a lot of other moving parts around it. All right, so thinking in terms of a linear equation, perhaps we start this by subtracting 20 from both sides. So we get 125, 1.3 to the x power equals 150. Now if I divide by 125 and do a reduction, right, we get 1.3 to the x power. I believe this will be 6 over 5. Okay, and now you have a couple of choices. You can do a straight out conversion, right, and base 1.3 is not a nice one, or you can apply any logarithm, and that's what I'm going to do. Since I applied the log, how about I apply the natural log here? So I'm going to take the natural log of this side, and whatever I do to one side, I do to the other. Here my power rule comes into play, so we have x times the natural log of 1.3 equals the natural log of 6 over 5. And so here, to get x by itself, I'll divide by the natural log of 1.3, and there's our answer. So x equals the natural log of 6/5 divided by the natural log of 1.3. All right, so that's what we call an exact answer, by the way. To get the approximation, I just turn to my calculator. So we've got the natural log of 6 divided by 5, right? And we're dividing that by the natural log of 1.3. And what I get out of that is x is approximately 0.694917 and some change. All right, so there you have it. So that's how we solve an exponential equation. Isolate the exponent, all right, and then apply a logarithm. You either just do a straight out conversion, or you apply any logarithm and get to your, essentially your change of base formula. So you're going to get here no matter what. Okay, so let's just keep doing some more. So the next one again is very similar to B. There's our exponential part right there, but there's a lot of other moving parts. So treating it like a linear equation, I'll first subtract 13 from both sides. We get 2e to the negative 3x equals, I believe that's going to be 62. Right? Divide both sides by 2, and we get e to the negative 3x equals 31. right? So again, you can think of this as a straight out conversion or applying a natural log. So if I apply the natural log to both sides, let me think of it that way, right? Over here we have a base e being composed with its base e logarithm. So we're left with negative 3x equals the natural log of 31. Divide by negative 3, and there's our solution. So x is the natural log of 31 divided by negative 3. Again, this is an exact solution. To get the approximation, I turn to the calculator and punch that in. So we have the natural log of 31, and we are dividing that. I like to use parentheses. Make sure you use the right negative, right? The negative we need is this negative down here, right? So negative 3, right? And when I punch that in, we get x is negative 1.14466624, yada yada, and some change. All right, so there's our solution to that guy. Again, I have base e, so I might as well just apply its inverse, right? So apply the natural log to both sides, and over here we have our inverse property in play, and we just keep solving for x. Okay, so there we have it. The next one's quite challenging because I have two different bases, right? Base 2 and base 5. So again, a straight out conversion is not going to be too helpful here. So why don't we apply something that's on my calculator, log or natural log. So I've done natural log here and here. So how about we do our common log? Again, it doesn't matter. The rules are the same for each. But if I apply the logarithm to both sides, here's what this problem will look like. So log base 5 of x plus 3. All right, in both cases, what I have is our exponential rule. So I take my power and I move it out front. Here, be careful because the power is x plus 3, and so put that guy in parentheses, right? Because we want to make sure that this power is being multiplied to log base 5. So we have x log of 2 equals x log of 5 plus 3 log of 5. All right, and then here what you got to remember is this represents a number. It's not a nice number, but it's a number. And what I have is I've got a term with x on this side and a term with x on it on this side. So what we usually do is collect all those x terms to one side and keep the non-x stuff to the other. So I'm going to start this by subtracting log base 5 from both sides. Right? So we have x log of 2 minus x log of 5 equals 3 log of 5. X is common here, so I'll factor it out. So we get x parentheses log of 2 minus log of 5 equals 3 log of 5. So to get this x by itself, I'll basically divide out that big old number there. Again, it's some number that's being expressed there. So x in this case, right, let me bring the thing that x is 3 log of 5 divided by log of 2 minus log of 5. Right, so that would be our exact answer based off of the work that we're doing there. Okay, and so an approximation, we would just turn to our calculator and kind of punch that in. Be careful with your parentheses. So up in the numerator, parentheses, I have 3 times the log of 5. So that's up in the numerator. Down in the denominator, parentheses, I've got log of 2 minus the log of 5. And close those parentheses out. So it looks like we're looking at negative 5.26941 and some change. All right, so there would be the value of that guy at that time. All right, so much harder to do because of the different bases, but apply a new logarithm, start using your powers, and then just use your algebra skills to get x by itself. And again, just log 2 and log 5 are numbers, so it's just almost like treating this as 2x equals 5x plus 3, right? We would have subtracted 5x from both sides, right? And got negative 3x equals 3. But what's nice here is those numbers are, we're used to seeing integers and messing around with them. Here, they're just we have to remember that this is a number. It's a number I raised 10 to get 2. This is a number I raised 10 to get 5. All right, so we're going to treat them just like we would have back in the day. All right, so there's your exponential equations. Again, the idea is to isolate the exponential part and apply a logarithm and take it from there. All right, so much harder situations coming next, but we'll do that in a new video.